Okay, this question is about the confidence interval again, but we're gonna be using the t table, right? In this case, we are unable to do it with the calculator, at least the shortcut way. We can use the calculation, but we have to know our formulas, right? So let's read the problem. So what I need here, so a large company, the director of research found that the average work time lost by employees due to accident was 100 hours. So 100 hours, this would be my average, which is the mean, right? I can go ahead and put the mean here. So the mean is going to be 100. Use a random sample. All right, so a random sample 21, so we get n equals to 21. The standard deviation of the sample, so the standard deviation of the sample, this is important, is 5.6. So we are not using the sigma, we are using the s because the sample, right? Well, it's supposed to be mu x bar, sx bar, but anyway, so this is going to be 5.6. All right, so this is again the s. Now, from these two information, what I know that the sigma is unknown, and I know the n is less than 30. All right, if these two conditions are verified, all right, you are using the t table. I hope it's clear, right? So and here is not or, both of them unknown and n less than 30. So you're using the t table. Okay, so estimate the population mean of the number of hours lost due to accident for the company using the 90. So the 90% here confidence interval. Assume all the variables are normally distributed, round to intermediate values. All right, so we're gonna try to do everything from scratch here. So let's put a small graph for this. So this is the information that I need. I don't think I need anything else. Yep. And the confidence interval the 90%, right? So now, if I will have to grab this is going to be my, again, my normal distribution. This is going to be the mean. It's going to be 0. Sigma is going to be 1. This is going to be the t values. And what I'm trying to do, I'm trying to define the 90% confidence interval. And the 90% is going to be in the middle. So we don't have a right tail or left tail. This is the mean equals to 100 basically here, right? So this is the 90% confidence interval. I can highlight it here. All right, so this is going to be 0.9000. all right, so what does mean? That means the tails, each one of them, each one of the tail, is going to be 1 minus the confidence divided by 2. And this is going to be 1 minus 0.09 divided by 2, which is 0.05 here. And this one is going to be the same, 0.05. The total area is 1. So now, what I'm going to do, I need to define, this is basically in the t values. So if I will have to switch right now to the x value, x bars, all right? So what I'm going to be doing, I'm going to, well, first of all, I need to define, okay, I'm not going to do that. First of all, I'm going to define here. So first of all, I'm going to define the t critical, right? They are really important. There are two values, t critical here, t critical here. So the t critical, I can use the calculator for this. Remember the calculator, you need to feed it the left side, the left tail here. That's the easiest way. And we know this tail is going to be 0.05. The n is 21, so degree of freedom here, degree of freedom you're going to be 20 n minus 1, which is 20. All right, so let's go to the calculator, and then we're going to go to second vars, and then I'm going to go to inverse t, number 4, enter, and I'm going to put 0.05, 0.05 here. Degree of freedom is 20, so make sure it's 20 here, and then that's it, right? So this is going to give you a value of t critical, and you're going to be negative because it's on the left side, so you're going to be minus 1.725. I can see. All right, I can leave it like that. The other one you're going to be symmetrical to this, which is 1.725. So now I'm going to make a transition to find the confidence interval. All right, so what happened with the confidence interval? It's the same graph. So I have the bell shape here. The only thing that changed is I'm not in the t-axis anymore. I'm using the x bars. So if I'm in the x bars here, the mean would be the 100. So that's the one that I got before. And the sigma x bar, right? So again, this is mu x bar and sigma x bar. So I'm using the central limit theorem, right? If you remember. And the sigma x bar, it can be the s divided by radical n. So the s is 5.6. 5.6 here, and the radical n is radical 21. So this is my environment, new environment. Now if I want to get the two confidence intervals, right, so remember I'm gonna cut this in such a way that I will get 0.9 in the middle. All right, so what will be this x bar here and this x bar here? So what will be this value here and this value here? So what we're going to do is there is an error that we're going to be calculating, which is e, the distance. And the error is going to be once you add it to the 100 and once you take it away from the 100. Or what is the error? The error is always equals to t critical times the sigma or the s, all right, for this case, divided by radical n. So you can calculate this value and you can get it. So what is the t critical is 1.725, which is that value over there. I'm going to multiply by 5.6 and divided by radical 21. All right, so I need this value. So as a value, I have it here. I'm going to keep it. I'm going to multiply it right now by 5.6. All right, 5.6, and then divided by radical 21. So square root here and 21 inside, right? Okay, and that's basically it. So this is my error, minus 2. Well, I take it positive. So this is going to be 2.1076. All right, I'm taking too many decimals, but it's fine. So now, how can I get the two boundaries? In order to get the two boundaries, this is the lower boundary. All right, so this is the x lower, x bar lower. This is going to be the mean minus the error. And the upper boundary, this is the x bar upper. This is going to be the mean least the error. And remember the error, I'm taking it as a positive value, right? Is 2.107. So that's it. So this is going to be 100 plus 2.1076. This is going to be 102.1076. I'll round it later on. And this one will be 100 minus 2.1076. So I can add 100 to the previous answer plus 100 here. And this is going to be 97.89235. All right, so I have the two answers. I'm gonna go and plug them in. So in here, if you see the lower one, they want to round intermediate values and at least to 3 decimal places, round the final answer to nearest whole number. So what is the nearest whole number for this? The nearest whole number, this whenever you round it, you're going to be 98. The nearest whole number to this, you're going to be 102. So this is what would be your answer, 98 to 102. So you're going to go back to the question and you're going to plug in the two numbers. This here is going to be 98 and this one over here 102. Okay.